Good day, this is Advanced Engineering Mathematics for Civil Engineers or FADMAT by Marvin M. Bertido. So our topic for today is about systems of linear equations. So for the intended learning outcome for this topic, it's in number 4. So we must be able to evaluate systems of linear equations using different methods. So in this topic, we will deal with different methods of solving systems of linear equations. So these are the methods that we're going to discuss for solving systems of linear equations. So we have two major methods, no? So it's yung letter A natin, it's direct elimination methods. And meron tayong anim na under dyan, okay? And we also have letter B, which is iterative methods. And meron tayong dalawa na pag-uusapan dyan. So this is number 2 ha, hindi number 4. Okay. So, we can express the following system of linear equations in matrix form or matrix equation. Okay, so let's say this is our system of linear equations. Okay, so we have three equations here, no? And all of these equations are linear. Okay, so X, Y, Z. Ayan. So yung A11, A12, yan yung mga coefficients no nung ano natin, nung systems natin. And itong B1 natin, B2, B3, yan yung constants ng equations natin. Okay, so we can rewrite this system of linear equations into its equivalent matrix form. So its equivalent matrix form, so here, yung una, these are the coefficients no of our equation. So yung A11, A12, A13 hanggang A33. Okay, and then yung X, Y at Z natin. So these are the variables. These are the unknown variables X, Y at Z. So you're just going to write it this way, and it will be equal to the constants, which are B1, B2, and B3. So this form, no, this matrix equation is actually equivalent to this system of linear equation. So kapag in-apply mo yung product, no, nitong matrix nung coefficients natin, tapos itong unknown x, y, z, so it will be equivalent dito. So let's say A11, A12, A13, tas multiply mo yun dito, di ba? So A11x, A12y, A13z, and yun ay equal sa B1. So ito yun yung equation na yun. Okay, so this is an equivalent kapag pinerform mo yung operation nitong equation na to. Now, yung unang ano natin, no, yung matrix of elements natin dun sa previous slide, wherein yung elements natin are from the coefficients ng equation natin. Yung matrix na yun ay tinatawag na coefficient matrix. So yun nga, lahat ng elements natin, it's from the coefficient of our equations. Okay, so coefficient matrix yung tawag doon. Now, meron din tayong tinatawag na augmented matrix. So yung augmented matrix, so aside from the coefficients of the equation, okay, so idinadagdag din natin dito yung constants of the equations, yung B1, B2, and B3. So gumagamit tayo nito, no, nitong symbol na to. So ano lang, parang dinadagdag lang natin at the right side of the coefficient matrix yung mga constants natin. So yun yung augmented matrix. Ulit. So now, let's discuss the first method of the direct elimination method for solving systems of linear equations. Okay, so we have here system of linear equations, no? So we have here three linear equations and meron tayong mga coefficients, okay, meron tayong constants, and meron tayong mga unknown variables which are x, y, and z. So kapag nag-solve tayo ng system of linear equations, ang sinosolve natin dito is yung mga unknown variables. Okay, so if you're going to use the Cramer's rule method, kailangan nating kunin yung yung magiging coefficient matrix niya. And yung coefficient matrix niya nga is just the matrix form na yung elements is yung coefficients nung equation natin. Now, if we're going to use Cramer's rule method, so to solve for the unknown variables x, y, and z, we're going to use this formula. Okay, so for x, this is equal to determinant of n of x over determinant a. Okay, wherein yung n of x, okay, or yung determinant ng n of x, I will discuss that on our next slide. And yung y naman natin is equal to determinant of n of y over determinant a. Yung z natin, determinant n of z over determinant of a. Wherein yung a pala natin dito will be the coefficient matrix. So you're going to solve for the determinant of your coefficient matrix. So now for the determinant of n of x, n of y, and n of z, it's just simply equal to the determinant, okay, of the matrix formed, okay, na yung column nung unknown variable na gusto nating mahanap, which is yung x, no, papalitan natin yung column na yun nung values nung constant nung equations natin. So yung equation, yung constants natin ay B1, B2 at B3. So isa-substitute mo yun dun sa column nung unknown variable na hinahanap mo or sinosolve mo, which is x. So this is the column of the x variable, di ba? Yung first column. So papalitan mo yan ng values ng constants natin. Okay, ganun din kapag determinant of n of y yung hinahanap natin. So yung papalitan natin dito na column is yung column ng y, which is the second column, and papalitan natin siya nung constants ng equations natin, which is b1, b2, and b3. And it is the same dun sa determinant of n of z. So yung hinahanap natin dito is yung variable z. So papalitan natin yung column ng variable z with the constants b1, b2, and b3. Now, let's take this as example. So we're going to solve problem number 1 using Cramer's rule method. To solve the problem number 1, so we have here two equations or two linear equations, no? And ang pinapahanap sa atin dito is yung variable x at saka variable y. And so using Cramer's rule method, kailangan muna natin isulat yung magiging coefficient matrix natin. So yung coefficient matrix natin, yung elements natin dyan, is yung coefficients nung equations natin, or equations natin, which is 3, 1, 2, and 3. So ito yun, no? So this is a 2 by 2 matrix. Okay, so to solve for the value of x and y, we're going to use this formula, determinant of n of x over determinant of a, and for y naman, determinant of ny over determinant of a. Wherein yung determinant of a, okay, it's just the determinant of the coefficient matrix, and that is just 3 times 3 minus 2 times 1, which is 7. So that is already the determinant of a. So isolve na natin yung determinant of nx. So x yung hinahanap natin dito, no? So we're going to replace yung column nung variable x, which is the first column, by our constants. Yung constants natin ay 2 at negative 1. So replace natin yan. So yung magiging ito ay 2, sa halip na 3, 2, i-replace natin yan by 2 and negative 1. And then yung remaining elements, it's the same, 1 and 3. Now, you're going to solve for its determinant, okay, and that will be 7. And yun na yung magiging determinant of n of x mo. Now, for the determinant of n of y, so y yung kino-consider natin dito. So we're going to replace the column of the variable y with the constants. Okay, so ni-replace natin. So sa halip na 1, 3, yung column 2 natin, gagawin nating 2 at negative 1. So solving for its determinant, it will give you negative 7. So yun na yung magiging value ng determinant of n of y mo. And using the formula, it will give you x equal to 7 over 7. So that will be equal to 1. And yung y natin, negative 7 over 7, it will give you negative 1. So these are the answers. Yung x natin ay 1, yung y natin negative 1. Now, for sample problem number 2. So we're going to solve this linear equations using Cramer's rule method. So we have three equations here. And we have three variables, x, y, and z. So yung first step natin, gawin mo muna yung coefficient matrix. So this is the coefficient matrix of this system of linear equations. And you're going to solve for its determinant. So yung determinant of matrix A using basket method, since this is a 3 by 3 matrix, is 42. Now, for the determinant of n of x yung kino-consider natin dito, let's replace the column of the variable x with the constants, which is 873. And solving for its determinant, it will give you 42. For the determinant of ny, y yung kino-consider natin, we're going to replace the column of the variable y, which is the second column, with the constants, which are 8, 7, and 3. Now, solving for its determinant, it will give you 84. Now, for the determinant of n of z, so we're going to replace the column of the variable z with the constants 8, 7, 3. So, solving for its determinant, it will give us 42. So, applying now the formula, so for x, it will be equal to the determinant of n of x over determinant of a, and it will give us 1. For your y naman, it will give you 2. And yung z naman natin, the answer will be 1. So these are the answer for this problem. X equal to 1, y is equal to 2, and z is equal to 1. Now, this is the second method of direct elimination method. So this is called Gaussian Elimination method. So yung process nung Gaussian elimination, ang una nating ginagawa is kinukuha natin yung augmented matrix of the system. So that is the coefficient matrix with the constants at the right side, no? Ayan. And then ang goal natin dito is to make the matrix in which every element below or above the diagonal elements is 0. So in short, kailangan natin na magawa yung augmented matrix natin or yung matrix natin as a triangular matrix. So triangular matrix yon kapag yung elements below or above the diagonal elements are 0. Tama? Ayun. So yung form na yon, yung triangular, upper triangular or lower triangular matrix na yon, it's also called Gaussian or Gaussian form of matrix. Okay, and we're going to use elementary row operations to reduce that matrix, okay, into Gaussian form. And yun nga yung tinatawag na Gaussian elimination. And as soon na magawa na natin yung augmented matrix natin as Gaussian matrix, okay, we can now solve the Gaussian matrix by back substitution. So this is the summary of the steps that we're going to follow in using this method. So the first step, we have to write the system of linear equations to augmented form. And then the second step, let the leading element or the first number of the augmented matrix be 1 by interchanging two rows or normalizing the first row. The leading element cannot be 0. So the first element, which is located in the first row and first column of the matrix, it should be 1. Now, if that element is not 1, we can use other rows wherein that element is 1. So we can interchange those two rows, or we can normalize that row if walang row na merong element na 1 in its first row, no, or the first element in the first row, we can normalize the first row. So what do you mean by normalize? So you're going to multiply that row, okay, the first row, to a number na yung magiging first element mo will be equal to 1. Okay, so that's how you normalize it. And hindi pwede na yung leading element natin ay 0. Okay, so yung third step natin, we have to reduce the augmented matrix to upper triangular matrix. So actually, pwede rin na lower triangular matrix. Okay, but in this case, okay, we will agree, okay, to reducing the augmented matrix into just upper triangular matrix. So yung upper triangular matrix na yun, yun yung binabanggit din natin kanina na Gaussian form, no, or Gaussian matrix. and tinatawag din siya na row echelon form. So we're going to reduce that by elimination. So yung ginagawa natin by elimination, we are multiplying any row by a non-zero scalar. So ibig sabihin, if yung normalized row natin, which is yung first row, no, wherein yung leading element ay 1, we can multiply that doon sa elements na gusto nating mapag-zero. Okay, and then after mo siya ma-multiply but by that non-zero scalar, we're going to get or we're going to subtract or add yung row na yon na pinagmultiplyan mo to your row na gusto mong mapag-zero nga yung element na yon. Okay, so in our problem, we're going to tackle this, no? And then after nga no, na magawa na natin na upper triangular matrix yung augmented matrix natin, we can now solve the values, no, by back substitution. So this is the example. We are asked here to solve the system of linear equations using Gaussian elimination method. So in here, we have variables x, y, and z, no? And we have 3 equations. Okay, so yung first step na kailangan natin gawin dito is gawin natin yung augmented form or yung augmented matrix, okay, of this system of linear equation. So this is the augmented matrix of the system of linear equations. So we have here the coefficients, no, yung coefficients nung equations natin. And then at the right side, yung mga constants natin. Okay, so yung first step natin, kailangan daw yung leading element ay 1. Ngayon, kung yung leading element natin is not 1, meron kang dalawang choice. Yung first choice mo, hanap ka ng row, okay, na yung first element niya ay 1. So in this case, wala tayong row na ang element niya ay 1. Okay, so we cannot just simply interchange rows kasi nga wala tayong row na merong leading element na 1. So what we're going to do here is normalize the first row. So to normalize the first row, okay, so ibig sabihin, kailangan nating mapag-1 itong element na to, itong 3 na to. So para maging 1 ito, we have to multiply the entire first row, okay, to 1/3 or by 1/3. So multiplying 3 by 1/3, that will give us 1. Okay, and that will be our new row, no? All of the elements in the first row will be multiplied by 1/3, and that will be the new first row. So this will be the elements in the new first row. So that will be 1/3 1/3 times 3 is 1, 1/3 times 2 is 2/3, 1/3 times 1 is 1/3, 1/3 times 8 is 8/3. So this and then yung two rows natin, no, yung second row at third row natin, it will just be the same. Now, ang goal natin dito in Gaussian elimination, makagawa tayo ng upper triangular matrix. So, ibig sabihin, yung elements below the diagonal elements should become 0. So, ito, yung 2, 5, at negative 3, dapat mag-0 yan. So, yung first na kailangan natin gawin, kailangan muna natin mapag-0 itong 2 at saka 5 in the second and third row. So, in order to do that, we have to multiply, okay, yung first row natin, okay, yung una is ito, yung element natin dito, which is 2. So, it will be multiplied by 2. Okay, so the entire first row will be multiplied by 2. And let us subtract yung second row natin, okay, and yung magiging difference niya will be the new R2 or the new row 2. Okay, so that will be 2 times R1, which is 1, no? 2 times 1, 2 times 1 is 2, minus R2, which is 2, 0. So, ito na yung magiging R2. Ganun din, 2 times 2/3, okay, minus 1, it will give you 1/3. And then, 2 times 1/3, minus 3, so it will give you negative 7/3. And then 2 times 8/3 minus 7, it will give you negative 5/3. So that will be the new row 2. Yung row 1 natin, it's still the same, ha? Ayun. Tapos para dun sa row 3 natin, okay, we're going to multiply yung first row natin, okay, by 5, since 5 yung kailangan nating makancel. So we're going to multiply 5 doon sa first row natin minus row 3. And that will be our new row 3. So that will be 5 times 1 minus 5, it will be 0. Okay, yun yung goal natin, no? Mapag-0 tong dalawa na to. And then continue lang natin. 5 times 2 thirds minus negative 3, it will give you 19 thirds. And then 5 times 1 third minus 4, it will give you negative 7 thirds. And then 5 times 8 thirds minus 3, which is 31 over 3. So that will be the new row 3. Now, we still have 19 over thirds dito, no, na kailangan nating mapag-0. Okay, so in order to do that, okay, we're going to use yung row 2. So dun sa row 2 natin, we have first to normalize. Kailangan muna nating i-normalize yung row 2 natin. Kailangan nating mapag-1 itong 1/3 para mas mapadali tayo, no? Okay, so normalizing the second row, we have to multiply 3. Okay, so dun sa entire second row natin, and that will be the new second row sa next matrix natin. Yung first row natin, it will be the same. Yung second row natin, okay, it will be 3 times 1/3, that will be 1. 3 times negative 7 thirds, that will be negative 7. 3 times negative 5 thirds, that will be negative 5. So this will be the new second row. And then yung third row natin will be the same. Okay, so ang goal nga natin, itong 19 thirds na to, kailangan natin mapag-0. So we can use the second row. We can multiply doon sa second row, 19 thirds, no? And then, ang mangyayari, i-subtract natin yung row 3 natin para ma-cancel itong 19 thirds, maging 0. And that will be our new row 3. So 19 thirds multiply to the whole second row. 19 thirds times 1 will be 19 thirds minus R3. Yung R3 natin is 19 thirds, so that will be 0. And then we have 19 thirds times negative 7 minus negative 7 thirds. It will give you negative 42. And then we have 19 thirds times negative 5 minus R third, or R3 pala, which is 31 thirds. Okay, it will give you negative 42. So this will be the new row 3. Now, this matrix, augmented matrix, is already in triangular form, no, or in Gaussian form. Kasi napag-0 na natin lahat ng elements sa diagonal, or lahat ng elements below the diagonal elements. Okay, so from here, we can solve this by using back substitution. So back substitution, kasi magsisimula tayo dito sa baba. Okay, pataas. So we have negative 42. Okay, so yung negative 42 natin, it's in the column na yung variable natin ay z. So that will be negative 42z is equal to our constant, which is negative 42. So this equation will be generated, negative 42z is equal to negative 42. And solving for z, it will give you 1. Now, for the second row, no, that will be y, 1y, which wherein ito ay 1, no, yung coefficient dito. So that will be 1y or y minus 7z is equal to the constant, which is negative 5. So we already have the value of z, which is 1. So we can solve for y, and yung y natin will be 2. Okay? So for the first row naman, no, that will be 1x plus 2/3 y plus 1/3 z is equal to 8/3. So meron na tayong y at saka z, we can solve for x. So solving for x, it will give you 1. So these are the answers, no? X equal to 1, y is equal to 2, and z is equal to 1. Now, for the third method, which is the Gauss-Jordan elimination method, this is pretty the same, no, with the Gaussian elimination method. So kung paano yung ginagawa natin sa Gaussian elimination, we will just continue it. Okay, so yung steps natin dito, the same yung unang step, no, with your Gaussian elimination. So we have to write the system of linear equations to its augmented form. And then yung second step natin, ganun pa din, no, kailangan yung leading element natin, okay, yung first element doon sa first row natin should be 1. Kung hindi siya 1, kailangan nating mag-interchange ng dalawang rows. Kung meron tayong row na merong first element ng first element dun sa row na yon na 1, we can interchange that dun sa may first row natin. Okay? Ngayon, kung wala namang element na or walang row na merong 1 na element dun sa first dun sa first element niya, we're going to normalize the first row. Okay? So, yun nga, bawal na ang leading element natin ay 0. Ayun. Tapos, yung third step natin, we have to reduce the augmented matrix to unit matrix. So, kung naaalala mo yung unit matrix, okay, yung unit matrix, lahat ng diagonal elements natin ay 1. And then, lahat ng remaining elements ay 0. Okay, so, ito yung kaibahan niya doon sa Gaussian elimination, no? Yung sa Gaussian kasi, kailangan lang natin siya gawing upper triangular matrix. So in this case, ang kailangan nating gawin doon sa augmented matrix natin, maging unit matrix siya. So yung unit matrix na yon, tinatawag din siya na reduced row echelon form. So kung yung kanina, yung Gaussian form natin or yung upper triangular matrix, tinatawag siya na row echelon form. Ito naman ay reduced row echelon form. Ayun. So gagamitan din natin ito ng elimination. So it's the same kung paano natin pinagzi-zero doon sa Gaussian elimination, yung mga kailangan maging 0. Okay, so we will apply that. So we have here the same example, no, na katulad nung sinolve natin sa Gaussian elimination. So now we're going to solve this using Gauss-Jordan elimination. So this will be the solution using Gauss-Jordan elimination. So as you can recall, dumating sa ganitong part, no, yung augmented matrix natin using Gaussian elimination, no. So refer ka na lang dun sa may first method natin or yun dun sa Gaussian elimination method. So it's the same problem, no. So dumating sa point na ganito na yung augmented matrix natin. Okay, so we're just going to continue this. So again, ang goal natin for Gauss-Jordan elimination, lahat ng diagonal elements natin mapag-1 natin. So itong negative 7/3, kailangan natin itong mapag-1. Tapos kailangan yung remaining elements maging 0. So itong 19/3, kailangan pa natin itong mapag-0. Yung 2/3, kailangan pa natin mapag-0. At yung 1/3, kailangan natin mapag-0. Now, para mapag-0 natin itong 9/3 at saka 2/3, gagamitin natin itong second row, no? So since 1 yung element dito sa may katapat ng 2/3 at 19/3, so we're going to multiply yung second row natin by 2/3 at saka 19/3. So that will be the new first row at saka third row. Okay, so para dun sa una, so we have to multiply yung second row natin by 2/3 para mapag-0 natin to. Okay, so that will be 2/3. Pero ang gawin natin, yung R1, yung row 1, yung isubtract natin sa may 2/3 R2. Kasi kapag ang inuna natin is yung 2/3 R2, tapos sinubtract natin dito sa may first row, ang mangyayari, magne-negative itong 1. Nagets mo? Magne-negative itong 1 sa panibagong first row natin. Tama? So we have to subtract yung 2/3 R2 from R1. Okay, so that will be R1 minus 2/3 R2. And that will be the new first row. So that will be R1, which is 1 minus 2/3 ng R2, which is dito 0, no? So ang mangyayari, that will still be 1. Now, 2/3 minus 2/3 ng R2, which is 1. Okay, so that will give you 0. And then R1, which is 1/3, minus 2/3 ng 5. Ay, mali. Minus 2/3 ng negative 7 pala. So that will give you 5. And then R1, no? So 8/3 minus 2/3 ng R2, which is negative 5. So it will give you 6. So that will be the new first row. Yung second row natin, it will be the same. Tapos yung third row natin, so itong 19/3 yung kailangan natin mapag-0. So we have to multiply yung yung row 2 natin by 19/3. Okay, minus yung row 3 natin. And that will be the new row 3. So that will be 19 thirds times R2, which is 1, minus R3, which is 19 thirds, that will be 0. And then 19 thirds times row 2, which is negative 7, minus R3, which is negative 7 thirds, and it will give you negative 42. And then 19 thirds times negative 5, okay, minus R3, which is 31 over 3, that will give you negative 42. So now, napag-zero na natin yung mga elements below the diagonal elements. Ang kailangan na lang natin, mapag-zero pa yung 5 at saka negative 7 at saka mapag-1 natin itong negative 42. So we have to normalize yung third row natin. Kailangan natin mapag-1 yung negative 42. So para mapag-1 natin yan, we have to multiply yung entire row 3 natin by negative 1 over 42. So, yun yung magiging new row 3 natin. So, negative 1 over 42 times negative 42, it will give you 1. And then negative 1 over 42 times negative 42, 1 din yan. Now, from this augmented matrix, kailangan na natin mapag-zero yung 5 at saka negative 7. So, in order to do that, we can multiply or yung R1 natin, no? Yung R1 natin, kailangan natin, or yung row 3 pala natin, rather, we have to multiply it first by 5. Okay, so mangyari, hindi natin pwede gawin na 5R3 minus R1 kasi magne-negative ito dun sa magiging new row 1 natin. So, ang kailangang mauna is yung R1 minus 5R3. Okay, so that will be R1, which is 5, minus 5 times R3, which is 1. So that will be 0. Yun yung magiging new first row natin. Okay? So it's still 1 pa din naman yung first element. Yung second element ay 0 pa din naman. And then we have yung negative 7, no? Kailangan natin ito mapag-0. Okay, so para mapag-0 natin yan, multiply natin yung row 3 by 7. Okay, and then add na lang natin yung row 2 since negative naman na siya dito. So that will be 7R3 plus R2. Yun yung magiging new second row natin. So that will be 7 times 1. Okay, plus negative 7, 0. So that will be 0 ito. And then we have 7 times 1, which is 7 plus negative 5. That will be 2. Ayan. So this will now be the reduced row echelon form, no? So this is already in identity matrix. So yung mga nakuha na constant dito sa may kanan, yan na yung sagot. So this will be the value of x, this will be the value of y, and this will be the value of z. So yun na yung sagot. And it's the same dun sa nakuha natin sa Gaussian elimination. Now, for the fourth method of direct elimination method, it's called matrix inverse method. So, we're going to use yung concept natin sa pag-solve ng inverse matrix, no? Ayan. So, yung step na gagawin natin dito, yung first will be, we have to write the given system of linear equations as a single matrix equation. Okay, so we're going to rewrite yung system of linear equations natin into its matrix form. So this will be the matrix form, no? Or kung sa-summarize natin or mas pasisimplihin natin yung matrix form na to. So yung matrix na to, yung coefficient matrix natin, no? I-denote na lang natin siya as A, no? Capital letter A. And then yung mga unknown variables natin, which is yung x, y, at z, let's say na capital letter x na lang siya, no? Is equal to capital letter B, wherein yung capital letter B natin, it represents yung constants natin na B1, B2, B3. So this is the matrix equation natin, simplified matrix equation, yung A times x equal to B. Now, yung second step natin, we have to solve the matrix equation obtained in step 1. Okay, we have to solve for the x or yung values ng unknown variables, no? Yung capital letter x, it represents yung mga unknown variables natin, x, y, and z. Okay, so in order to solve the values of unknown variables x, y, and z, so imumultiply natin both sides nung matrix equation natin by the inverse of coefficient matrix. So yung inverse ng coefficient matrix natin ay a raised to negative 1. And then, yun nga, multiply natin siya both sides. So, it will be multiplied here, a raised to negative 1 times a times x. And ganun din sa kabilang side, yung b natin mamumultiply by a raised to negative 1. Now, recall mo na yung a raised to negative 1 times a is just equal to identity matrix. Tama? So, kapag minultiply mo yung identity matrix dito sa may x, it will just be x. Okay? Or yung x, y, and z. Now we're going to use this formula, yung unknown variables x, y, and z natin, equal siya sa inverse matrix ng coefficient matrix natin times yung b, which represents the variables of the constants. Or the constants pala. Yung capital letter B, it represents the constants, B1, B2, and B3. Now, let's solve this linear equations, system of linear equations using matrix inverse method. So for our first step, okay, we have to rewrite this into its matrix equation. So this is the equivalent matrix equation of that system of linear equations. Okay, so this will be the coefficient matrix A. And then these are the unknown variables x, y, and z. And these are the constants that will be 2, 2, and 3. No? So now we will multiply both sides by a raised to negative 1, which is the inverse matrix of our coefficient matrix. Okay, so again, yung a raised to negative 1 times a, class yun ay equal sa identity matrix. Okay, kung naalala mo dun sa may formula natin sa pag-solve ng inverse matrix. So, yung identity matrix niya will be this way. Yan ay 3 by 3, since 3 by 3 yung coefficient matrix natin. Times yung x natin, which is yung x, y, and z. And it will be equal doon sa may inverse nung coefficient matrix natin. So, dito, na-solve na yung inverse nung coefficient matrix natin. So, you just have to solve this using the either of the two methods na pinag-aralan natin sa inverse, pagkuha ng inverse ng matrix. So ito na yung lumabas na inverse ng coefficient matrix natin times the constants natin, which is 2, 2, and 3. Now, if we're going to perform the operations, ang operation natin para dito sa left side ay multiplication. So it will just give us this product x, y, and z. So it will just be x, y, and z. Since minultiply lang natin siya sa identity matrix niya. So ito lang din yung magiging product niya. Now, solving for the product naman nung a raised to negative 1 at saka yung b, ito yon. So this will give you negative 3, 14 over 5, and 13 over 5. Now, these values will be the values of x, y, and z. So x equal to negative 3, y is equal to 14/5, z is equal to 13/5. So ganun lang siya kasimple.
That concludes our session. I hope you learn. To see more videos about advanced engineering mathematics for civil engineers, please hit the subscribe button. Thank you.